Hey guys, in this video we'll be explaining how to derive a difference equation from a block diagram. In these diagrams, xi represents the input signal, yi is the output signal, and arrows indicate direction of data flow. The cross represents multiplication, the plus addition, and the z to the negative m represents an m sample delay. A difference equation is a mathematical representation of your system, and writing your system in this form should make it easier to code up. So let's start off with a straightforward block diagram, this feed-forward comb filter. If we try to eyeball it, we can see that your output
is just going to be your input times this coefficient VL plus your delayed input times your feed-forward coefficient. And if it was always this easy, then there would be no reason for us to make this video, but things actually get a little more complicated when you have feedback. So if we try to apply that same method to the feedback filter, we can start off by saying that there's a multiplication of ff at the end, so that everything needs to get multiplied by the ff. What is that everything? It looks to be x of I plus a delayed xi weighted by this feedback coefficient. Great, and then if we just multiply that out, we get feed forward x of I plus feed forward feedback x of I minus m. And this is actually wrong. And where we went wrong is that this signal here, it's not a delayed xi. This addition from the past comes into play again.
So we need to use an internal variable to represent the spot in the diagram.
So if we define that line as say, let's change to black for correct, v of I, we can solve for v of I and basically just say, it's pretty clear that y of I is just this v of I signal times ff. But what is this v of I? V of I is x of I times a delayed v of I by the feedback coefficient. And that can pretty much be it. But if we want to write it in a single line, we can just use this first equation and substitute in for the second equation. So if we move this feed forward to the other side, we can just replace vi with y divided by ff. So yi divided by ff equals x of I plus fb of y I minus m divided by ff. And if we multiply both sides by ff, we get this equation.
So here's the same equation without all the crossouts, and in comparison with the first one derived. So you can see there's a difference. This first one's wrong. So you really have to define these internal variables in order to derive the correct equation. Thanks.